morning, I'm Alex Marty with Colton Noble. We're lab group 6B, and this week we're doing lab 9 optical testing with the Shack Cube Interferometers. And up here I have a drawing of our Shack Cube Interferometer. So we have a laser going through an objective, which is going into the Shack Cube, which is just a beam splitter with a spatial filter cemented on one, on one side to clean up the beam, and a lens cemented on the other side that is our reference surface. And this lens is positioned such that reflection off of it comes to focus right on the back surface of the cube, which is where the center of curvature is for that surface. And we position our test surface the appropriate distance away such that its center of curvature is also on this back surface. So we get interference on our screen here, and that's from the reflection from the reference surface and the reflection from the test surface interfering as they cross at the same point.
Hi, I'm Colton, and I'm going to describe to you the actual physical setup of the Shack Cube Interferometer, which Alex talked about earlier. And so here's the helium neon laser. Here's the microscope objective, which brings the light to a focus at the spatial filter of the Shack Cube Interferometer, the reference surface, and the test lens. And so we've got this set up now to show some basic fringes, and what we have here is a bullseye pattern, and this means that there's power. There's the radius of curvature difference between the test wavefront and the reference wavefront, and so you get these rings which are characteristic of optical power. And as I move the reference lens back in, the test lens back in towards the interferometer, you can see that the rings are being reduced because the wavefronts are starting to match. And we can bring that to a perfect null like that. So now we have a perfect null in the setup. It's completely nulled. We're going to back out, and I'm going to demonstrate that decenter moves the fringe pattern, the center of the fringe pattern, to one side and to the other. And so as I move it back and forth, you can see the effects of decenter on the fringe pattern. You can do the same thing with tip and tilt. So I'm going to go ahead and tip it up, and you can see that the fringe goes down. I'm going to tip it down, and now you can see that the fringe centers also go down.
Alright, so for this part of the lab, we have, instead of the mirror, as we showed before, we have substituted in the second of the two lenses that we have tested. And we're testing the front surface, which is the concave surface of this meniscus lens. So we get the same effect with the that we had with the mirror, where that surface acts as a reflecting surface, and we have its center of curvature on the back surface of the Shack Cube, and we see fringes. And this is about our best null, and we see that there's a lot of spherical aberration. So if we add a little bit of defocus, just as with the mirror, we see the same ring pattern, and if we use decenter to add tilt, we see that our ring pattern moves left and right, just as it did with the mirror.
Okay, so now we're going to wrap up the lab. What we're going to show you is the difference between the interferograms with the lateral shearing interferometer and the interferograms with the Shack interferometer. And so we're going to use this Dr. Wyant's online Mathematica software to demonstrate. And so this is the interferogram for the Shack interferometer when it has 2 waves of spherical in it. And so you can see it's characterized by the nice rings, concentric rings. And then if we go and look at the lateral shearing interferogram, you can see the definite contrast and difference of the bowing of the spherical that almost looks like coma in a Shack interferometer. Okay, so now we're going to go back. We're going to zero out the spherical aberration, and we're going to add some focus to see what this looks like. We'll add 3 waves. We'll evaluate this, and we can see that we get 1, 2, 3 bright rings of in the Shack interferometer, which means 3 waves of focus. When we put 3 waves of focus in the lateral shearing interferogram, evaluate, we get straight lines. And so this is the difference between between how these actual interferometers actually interact with each other. So in the lateral interferometer, you get straight lines for when you have focus error, and in the Shack screen you get concentric rings. One more interesting thing is that we're going to go ahead and zero out the focus now, and we're going to add 3 waves of tilt in the 0-degree axis. We evaluate this, and we now see 3 straight. We see 1, 2, 3, 4, 5 straight bright lines, demonstrating tilt in the Shack interferometer. And when we do this for the lateral shearing interferometer, I'm going to zero out the focus. 3, evaluate. We see nothing because the lateral shearing interferometer is insensitive to tilt. And so in this lab, we've demonstrated some alignment techniques. We've showed how a Shack interferometer works. We've showed how perturbations in the alignment affect those interference fringes. And we've demonstrated the usefulness of the Shack interferometer in an optical lab setting. And that's it for this week. This is Group 6B out.